Hello friends, today we try to build the concept of electrostatic potential energies. Then what is potential? Potential, it is nothing but it is the strength or ability to do some work. And potential energy, it is the energy stored in a body due to the work done against an external force or field. Water stored on the buildings has some potential energy, and compressed springs have also potential energy, or an object raised against the gravitational force is stored in the body as potential energy. Here, consider a spring fitted to a rigid support, and to other end a wooden block is connected, and now the spring is in normal state. There is no external force acting on it. When an external force that compresses the spring, or external force, it can elongate the spring. If the force is acting in this direction, the spring elongates. If force is acting in opposite direction, the spring gets compressed. In compressed state or in elongated state, the spring acquires some energy, or an opposite force is developed in the spring, and that is called spring force. Therefore, when a spring is compressed, the compressed force acts on it, and when force acts on it, work is done by the external force. This work done in compressing the spring is stored in it as potential energy of spring. And now, if the force, external force is removed, the potential energy stored in it does work in opposite direction. Therefore, the wooden block starts moving. That means the potential energy is converted into kinetic energy, and potential energy of the spring is given by U is equal to half kx square, where k is spring constant and x is displacement of the spring, and it is converted into kinetic energy when external force is removed, and is given by kinetic energy Ek is equal to half mv square, where m is mass and v is the speed. Thus, using this relation, v can be speed of the block can be calculated. Or consider the surface of earth. The surface of earth is considered as zero potential. The potential on the surface of earth is zero. When an object on the surface of earth is raised against the gravitational pull, work done by the external force is positive, and this work done is given by W is equal to mgh, force into displacement, that is work done, and this work done is stored in the body as gravitational potential energy. Therefore, W is equal to U is equal to mgh. When force is removed, the body starts falling downward, losing its potential energy, and the body gains an equal amount of kinetic energy during the motion. Therefore, and here kinetic energy is given by Ek equal to half mv square. At any instant of motion of the ball, the sum of potential energy and kinetic energy remains the same. You have studied in PUC first year science. And now, what is electrostatic potential energy of system of charges? Potential energy or electrostatic potential energy of a single source is zero. Consider three charges Q1, Q2 and Q3 placed at infinite distance. They are placed at infinite distance from a system. From a system, these charges are placed at infinite distance, and at infinite distance there is no force between Q1, Q2 or Q1, Q3 and Q2, Q3. Therefore, potential at infinity, V is potential at infinity is equal to 0. Here also potential at infinity is equal to 0. V infinity is equal to 0. And consider a configuration A, B and C. Then what is the work done in moving a charge from infinity to the point A? According to Newton's first law of motion, the bodies which are at rest continues in the state of rest. The bodies which are in uniform motion, they move uniformly. Here Q1, Q2, Q3, they are at rest at infinity. Therefore, when a small jerk or small force is given to Q1, the charge Q1 starts moving in this direction. And there is no friction or air resistance or any electrostatic force acting on the charge. Therefore, it moves uniformly up to A. Therefore, Q1 is moved to the point A. Then what is the work done in this process? In this process, work done in moving a charge from infinity to point A is equal to 0. This is because there is no frictional force, no air resistance and no electrostatic force acting on the charge Q1. Therefore, work done on it is equal to 0. If work done is 0, then according to definition, potential electrostatic potential energy, it is defined as it is the work done in moving a charge from infinity to a point in an electrostatic field. There is no electrostatic field, therefore work done is 0. Therefore potential energy U is also equal to 0. Hence potential energy of a single charge is always equal to 0. Therefore, we calculate potential energy of system of charges. Then the work done in moving a charge Q2 from infinity to the point B. Before that, we calculate what is the potential at B due to charge Q1. The Q1 charge produces electrostatic field around it, and the field due to Q1 is up to here, and beyond this region, this is called infinity region. And let B be a point at which Q2 is moved. And when a small jerk is given to Q2, it moves up to this point, because there is no force acting in opposite direction. But as Q2 comes near to this point 0, because here O, at O, potential at O is equal to 0, because force is equal to 0. Electrostatic force due to Q1 is equal to 0. Hence, potential at O due to Q1 is equal to 0. And potential at B is Vb. And potential at B due to charge Q1 goes on decreasing, and it becomes 0 at O. It becomes 0 at O. Therefore, potential at B is equal to, we have derived in previous classes, that is potential due to a charge is K Q upon R. Here Q1 is the charge, therefore K Q1 upon R12. R12, where R12 it is the distance between A and B. Consider this as the first charge, it is second charge and third charge. Therefore, distance between AB is R12. R is the distance and R12 is distance between 1 and 2 charges. Clear? Then, according to definition, work done in moving a charge from infinity to point B. K2 is moved from infinity to point B, and that is equal to charge into potential difference, and that is equal to charge is Q2 is moved, hence Q2 into potential difference between B and infinity is, potential at B is Vb minus V at infinity, but V at infinity is equal to 0, hence work done in moving a charge from infinity to the point B is equal to Q2 into Vb. Q2 into Vb. Therefore, work done in moving a charge from infinity to the point B is equal to K2 into Vb, and Vb equal to K Q1 upon R12. That is equal to K Q1 Q2 upon R12. This is the work done in moving a charge from infinity to the point B. Now, what is the work done in moving a charge Q3 from infinity to the point C? To do this work, it has to overcome repulsive forces due to Q1 and Q2. Q1 and Q2. Therefore, find the potential at C. Potential at C due to charges at Q1 and Q2. Potential at C due to Q1 is K Q1 upon R12, R13, because R13 it is the distance between first charge and third charge. Therefore, Vc, potential at C, is equal to sum of potential due to Q1 plus Vc equal to potential due to Q1 plus potential due to Q2. That is equal to potential due to Q1 is K Q1 upon R13. R13 is the distance between A and C, or first charge and third charge, plus potential due to Q2 at C. Let the distance between second charge and third charge, or B and C, is R2, 3, second charge to third charge, that is equal to K Q2 upon R2, 3. Therefore, work done in moving a charge from infinity to the point C, it has to overcome repulsive forces due to Q1 and Q2. And this work done in moving a charge from infinity to the point C is equal to charge Q3 into potential difference between C and potential at C and potential at infinity. That is Vc minus V infinity. But V infinity is equal to 0. Hence, W from infinity to C is Q3 into Vc equal to K Q1 upon R13 plus K Q2 upon R23. Again, work done in moving a charge from infinity to C is equal to K Q1 into Q3 upon R13. K Q1 Q3 upon R13 plus Q3 into KQ2 can be written as K Q2 Q3 upon R23. This is 1 3 1 3 2 3 2 3. This is the work done in moving a charge Q3 from infinity to point C. Therefore, total work done W is equal to work done in moving a charge from infinity to A plus work done in moving a charge Q2 from infinity to B plus work done in moving a charge from infinity to point C. That is equal to work done in moving a charge from infinity to A equal to 0 plus work done in moving a charge from infinity to B is K Q1 Q2 upon R12 plus work done in moving a charge from infinity to C is K Q1 Q3 upon R13 plus K Q2 Q3 upon R23. This is the total work done. And this total work done is stored in the system of charges as electrostatic potential energy. Got it? What is potential energy? Electrostatic potential energy. It is the work done in moving a charge from infinity to that location is called potential energy. Potential energy is nothing but it is the work done in moving a charge from infinity to that configuration, or at initial configuration Q1, Q2 and Q3 they are at infinite distance. Therefore, this is the initial configuration, and in this initial configuration potential is 0 and potential energy is also equal to 0. And when they are brought to the final configuration, that is ABC, some work has to be done to move all the charges to the final configuration, right? Therefore, the work done in moving a charge from initial configuration to the final configuration is called electrostatic potential energy. Thank you.